since the release of their new product, which is a next-generation robot that has amazed audiences with its increased walking speed and significant weight reduction, in addition to the newly added sophisticated fingertip sensors that represent a true leap in robotic capabilities. Tesla has been the center of attention in the tech community. In this video, we explore the exciting field of robotics and pay particular attention to the most recent developments in Tesla's second-generation bot. Additionally, we hear from one expert who believes there is a big surprise in store for the Tesla bot. Elle stated that they plan to begin productive work in the factory sometime in 2024. And I firmly think that Elon said as much. Prototypes are simple. When it comes to humanoid robots, prototypes are difficult to produce, but mass manufacturing will be simple. Having founded two robots firms and keeping a keen eye on industry trends, this specialist has a wealth of knowledge that I've always felt certain they can produce quite quickly. Hit the like button and subscribe to Tesla Insights before we begin. Join us as experts uncover hidden Easter eggs and delve into the minute aspects of this groundbreaking creation. Let's get started, shall we? Last week, when Tesla introduced their new bot this past week, the tech community was agog. Marvel's increased gait and substantial weight loss really pleased me. Interestingly, it now has advanced finger sensors and honed hand talent, indicating a breakthrough in robotic capabilities. The expert discusses the technological feats accomplished in lowering the bot's weight by 10 kg and brings up intriguing aspects regarding its weight, which was originally estimated to be roughly 125 pounds. We contrast this with other available robots, such as Boston Tesla, stands with a dynamic spot and digit to measure where the nuances of the bot's parts, such as actuators and battery packs, are thoroughly examined by Scott, demonstrating the complex engineering required to reduce weight without sacrificing functioning. The discussion devolves into technical details as Scott explores possible avenues for weight loss. He surmises that material modifications, such as switching to plastics and manufacturing efficiencies, may have been crucial. This modification affects the bot's weight as well as its maneuverability and productivity. Even if the weight of the Tesla bot has been reduced by a significant 10 kg, many are still curious about its precise weight, which piques the interest of tech aficionados. Scalability and mass production are more important considerations in Tesla's approach to robot design than just usefulness. The bot of the second generation. The bot's pelvis design has been simplified, combining what were once separate front and back sections into a single piece. This reduction of parts not only lightens the load, but also streamlines production, potentially allowing for rapid, cost-effective manufacturing. The bot appears sleeker and more refined, ready for large-scale manufacturing. The changes aren't just cosmetic, they are strategic. The bot's improved walking speed, which is now 30 faster, is the subject of further discussion. However, its actual speed has not been quantified, leaving us to speculate. Tesla has stated that the bot's speed should not exceed 5 mph to ensure safety, but for practical purposes, such as factory work, a speed of approximately mph is more than sufficient. Based on the bot speed analysis, it appears to travel at about 1.5 m per second, or just under 2 mph. This makes the bot ideal for industrial environments where efficiency and safety are paramount, top priority even while the Tesla bot is mostly being used as a demonstration model right now. Its capabilities indicate that it will soon be a useful tool in real-world situations. The issue yet remains. Is the Tesla bot ready for factory use today? Initially, Tesla's first-generation bot counts were probably not more than 20. Surprisingly, this small number proved adequate for training purposes, greatly supported by advanced simulation techniques. This defies previous expectations that at least 100 bots were required since Tesla has plenty of other components like batteries and FSD chips. The actuators are the key focus for scaling production. Looking ahead, we anticipate seeing a gradual increase in production numbers. Initially, several dozen bots might be deployed in November. Effective training is a crucial component in Tesla's robot development. These sophisticated parts essential to the bot's functionality are expected to be ready for mass production around November. Several sites for testing and training as the production process moves forward. By the end of the next year, we anticipate a major increase in production. Depending on the effectiveness and finalization of the design, hundreds of these robots may be manufactured. While cautious in his predictions during earnings calls, Tesla CEO Elon Musk has suggested that these robots could be working in factories as early as next year. The robots have a high chance of being operational by mid-year. The challenge of moving from prototype to mass production, which is often a difficult task in robotics, seems doable for Tesla's humanoid robot. One noteworthy feature of the robot's design is its emphasis on safety and compliance, particularly in a factory setting. For example, the earlier concerns about pinch and poke hazards have been addressed with modifications like elbow guards and potential fabric coverings for more delicate areas reflect this. In terms of design advancements, Tesla's dedication to building a robot that can safely work alongside humans, there have been notable improvements. The robot's dexterity and capacity to navigate confined areas have been improved by the actuator's new placement, which permits a more compact wrist design. For better functionality, the hands have undergone a full redesign and are fitted with new sensors. These enhancements are not only aesthetically pleasing, but also useful. The robot now displays a more natural walking gait because of breakthroughs in foot and hip mechanics. Even the pelvis, though kinematically unaltered, has a new design that adds to a more compact and efficient form. The robot's walking pace has increased by 30 as a result of this heel-to-toe movement, demonstrating Tesla's dedication to ongoing improvement. The design of the second-generation bot's shoulders is one obvious modification. The robot's servo axis was originally horizontal, but it now has a little 8-dig angle, which increases range of motion and prevents problems like the polar singularity. Even though it seems small, this change greatly improves the robot's function. There have also been interesting modifications to the elbow mechanism. According to our thorough analysis, the elbow mechanism appears to be the same, but its packaging has changed for practical reasons, possibly to accommodate cabling or cooling needs, which begs the question of what the black fabric in the new model's interior part conceals. It is evident that these design modifications improve the robot's operational efficiency and safety. In addition to being aesthetic, the elbow desires a chance regarding power supplies. The protruding hazard is now neatly covered with hard plastic and cloth, making it safer and more streamlined. Perhaps the robot's design was changed to make room for a different kind of battery setup, although it's speculated that Tesla has moved to using larger 4,680 cells instead of 2170 cells, given the energy density and supply variables at the moment. It's more likely that the robot is still using the 2170 cells rearranged for optimal efficiency. Fans are a known component. Although cooling techniques have also been discussed, there's been conjecture over the utilization of liquid cooling mechanisms to sustain ideal temperatures for the internal electronics of the robot. The robot's tethering system has changed, with the attachment sites shifting from the head to the shoulder region. This is another intriguing finding. Reducing the strain on the neck actuators and more evenly distributing the weight, this modification shows careful engineering to guarantee the longevity and performance of the robot. 3 Optimus models can be seen in a recent clip varying in the construction stage. This unexpected revelation was first brought to light by Claudia Moe of John's channel and shows the quick advancement of Tesla's robot research. One area of interest has been the emergency off switch, which is usually found behind the robot's neck. However, recent footage lacks the visible I button, raising questions about its new location. Upon closer inspection, a red button appears to be located at the robot's lower back, an unusual location for such a vital component. Next, we examine the robot's longevity and energy efficiency. There has been doubt regarding the bot's ability to work an 8-hour shift on a single charge, notably that concludes our update on the Tesla bot. Please let us know what you think by leaving a comment below, and remember to like and subscribe to Tesla Insight. It appears that the focus is now on improving the AI and making sure the bot is reliable in lengthy tasks without frequently breaking down.